Welcome back everyone. So in this video let us start with on some important mathematical calculations. So first we'll start with the easy thing, that is on matrices. Okay, so we'll learn how to write down matrices, input matrices into the system, do perform basic operations on matrices like that's addition, multiplication, and you can also do division of matrices. Actually it's called taking inverse, but here it is referred to as division. Okay, so 1 divided by a gives you the I divided by a gives you the inverse of e. That's how it's working over here. Okay, so that being said, okay, so what else can we do? Yeah, we'll also learn how to find eigenvalues and eigenvectors of a given matrix. Okay, so that will be one important thing which we'll be studying here, and other basic things which are there obviously of matrices can be done here. Okay, so let us start with the codes. Manually switch here. Okay, so here we are. So this is the thing. Yeah, so now these are all the commands which are written long back. So I'll just empty this code. So if you type CLC, it clears the console. Okay, so say yes, and so we're starting afresh now. Okay, but notice that the console has been cleared over here. Notice here that the variables which are defined are still here. They're not deleted from the memory. Okay, so that is not so easy to delete the variables, but you will have to add some more commands and get them deleted. Okay, yeah, by the way, if I switch off this session right now, means if I switch off if I close the program, okay, if I close the program, all the variables will get deleted. Okay, they are not saved in the long term memory, they are just there for the short term memory. Okay, CLC only clears the console where the commands are written. Okay, so let us start with defining matrices. So we'll start with matrix 1. So if I want to enter a 3 by 3 matrix now, okay, so let me show you what I'm talking about. Okay, so let me use this. Oh wait, I'll have to put these things on. Just wait a moment. Okay, so just see this. So suppose I want to enter this matrix A is equal to 1, 2, 3, 6, 7, 8, 5, 6, 4. So this is the matrix which I want to enter into my system. Okay, enter into SciLab. Okay, so this the corresponding command for this will be where is the thing, M1. Now there are two ways of doing this. You can either write 1 space 2 space 3 and the end of the row it's signified by a semicolon. Okay, then next 6 space 7 space 8. Okay, this gives the end of the row, right? Then 5 6 4. Okay, 5 6 4, end of the matrix. Okay, press enter, you'll get the output here. Okay, so this is one way of entering the matrix. Another way of entering a matrix will be I'll use small m. Okay, small m, I'll write it as 1 comma 3 comma 4. Okay, semicolon 3 comma 2 comma 6. Okay, end of this thing. So this gives you a 2 by 1 2 by 3 matrix, sorry. Okay, so this is how you enter a matrix into the system. Okay, so now for some simple operations can be defined, but I'll have to enter some more matrices. So let me enter some more matrices. A into A will define it as 3 4 5, end of the row, 3, 3, 5, sorry, space 5. Okay, if you don't leave space, it's going to read the number as a same number. If you write 3, 5, it will read it as 35. So better leave space there. Okay, so 2, 1, 4, end of the matrix. Okay, so this are matrices we have defined. So now let us learn some basic operations here. So a plus m can be done. We'll get this as your answer. This is direct addition, term by term addition over here. Then you can also define a star that is multiplication. Okay, a star m, that will give you this. Okay, yeah, so you can also define here defined c can be defined equal to a star m. This will give you this same thing as above. Okay, so now why I did this, yeah, now to define c minus, sorry, now to define b as equal to c minus m, c minus, we'll just check commutativity here, c minus m star a. So the matrices are commutative, b should be equal to the 0 matrix, which it's not. Okay, so the product of those two matrices was not commutative. We'll study some other ways of doing this later on, how to check the matrices are commutative and all. But right now this is a manual way of just checking whether the product of the matrices will be equal to 0 or not. Okay, so anyways, c minus a star m, this should give you the 0. This is going to give you 0 because a star m is c only. Okay, yeah, so let me define identity matrix. The identity matrix is defined as 1 0 0 space 0 1 0 1 0 space, end of the row, then 0 0 0 0 1. Okay, so this is your identity matrix. Okay, observe that a star I is going to give you the matrix A again. Okay, two same matrix it was, no? I don't even remember. 3 4 5 2 3 5 and 2 1 4. Yeah. Okay, so that's happening. Now notice this here. If I call this matrix as A B C D E, I don't use C and D. I already see. Never mind. E I won't use them. E and D I'll reserve for eigenvalues and diagonal matrices later on. Okay, so A B C D E F G. So let me use the alphabet G. Okay, so how to find inverse over here? Simple. So inverse of a matrix, see, how do you define the inverse of a matrix? If G is the inverse of A, okay, you write A into G becomes equal to I, right? So in other words, G is equal to I times A inverse. This is what you'll anyways, that this thing is there, commutativity is there, but still I'll studied it as A inverse into I. Okay, this is the way of finding G, if G is actually the inverse, and this will become A inverse, right? So G is equal to A inverse if this is the thing. Alright, so now basically what you do is you kind of do this pre-multiplication with A inverse on both sides if it exists, and then you end up in finding G. Okay, yeah, but you don't know A inverse, right? I kind of framed my sentence wrong. uh, never mind, this sentence was not framed correctly what I just said, but try to understand that G is equal to A inverse if this statement is true. Okay, so if A G is equal to I, this implies that G is equal to A inverse. Okay, yeah, this also requires the other condition that G into A should be equal to I. Okay, and then only you can say this, otherwise it will be only the right inverse or left inverse. Yeah, assuming that this is not a square matrix, but if you are talking about square matrices, okay, then there's nothing to worry about. Just say that A is a square matrix first. Let's be a little specific in what we talk. Square matrix. Okay, for square matrices, left inverse and right inverse are the same things. Okay, so in other words, what you did here, you had AG. Another way of looking at this is you had AG is equal to I, right? So what did you do? You wrote G as I upon E. Now we rarely write this notation like this. We don't divide matrices with the division sign, and there's nothing called division of matrices also. But the SciLab has been programmed like that using this notations. Okay, when I'll type the command now that G is going to be equal to I divided by A. But what is actually happening here is that it's doing I into A inverse. Okay, and it's going to give you the final answer as G is equal to A inverse. Okay, because I into A inverse is going to become this. Okay, actually matrices cannot be divided, keep that in mind. Okay, so moving on, where's the program? Yeah, so G is equal to I divided by A. So if we got this thing here. Okay, so this is the inverse of A. Okay, so this is one technique of finding A inverse. Now one of the applications of this will obviously be doing this. Now if you have a system of equations to solve, okay, let us assume that we have a system of equations to solve over here. I am given the equation 3x plus 2y plus z is equal to 4 and 4x plus 7y minus 2z is equal to 1. Okay, and 5x minus 2y plus 3z. Okay, this is going to be equal to 3. So you have to solve this equation here. Okay, I want to solve this using SciLab. Okay, so we know that this can be expressed in this form: 3, 4, 5, 2, 7, minus 2. Okay, and 1 minus 2 plus 3. Okay, x, y, z. This is equal to 4, 1, 3. Okay, 4, 1, 3. So you have A into x column vector is equal to B. Okay. So what should be x over here? X will be B divided by A in SciLab notation. Okay, so let us do this now. So the matrix given to us is 3, 2, 1, 4, 7, minus 2, 5, minus 2, 3, and the vector B is 4, 1, 3. So let me enter these things here into SciLab, then we'll get the answer. Yeah, console. Okay. So I'll call the system of equations. So I'll enter this matrix as a S. So yeah, S is equal to 3, 3, 2, 1, end of the row, 4, 7 to end of the row of 4 7 minus 2, sorry, 4 7 minus 2, 5 minus 2, 3. Okay, end of the matrix. Okay, so this is my S matrix. Then I have to enter the B matrix. I've already used the alphabet B here, no? Never mind, I'll put the small b. So this is going to be a column matrix, right? So how do you enter column matrices? Write the first row, end of the row. Okay. Second row, end of the row. Third row, end of the matrix. Okay, so this is your column vector 4 1 3. Notice that had I done this now, keep in mind that you have to use semicolon over there. If you don't do that, see what will happen. If you just use ordinary comma, 4 comma 1 comma 3. Okay, what this gives you? This gives you a row matrix. Okay, so keep in mind when you are entering a column matrix or column vector, you have to use those colons over there. Okay, so that is there. After using those colons, yeah, we get this. So now I want to define my answer x, right? So I'll define capital X to be equal to the answer to the problem is b, small vector b, divided by a. Okay, so that gives me, oh wait, something happened here. I entered the wrong code, I think so. Let me just check. Sorry, I had made a mistake with the command. This is for division only. For inverse, no, we use this. X is equal to. By the way, the matrix which I was using was S, not E. So S backslash B. Okay, so this is how it is written. Okay, and this is your answer to that system of equations. Okay. And just note that the command is S backslash B. It is not what I said earlier. Okay, so it is written in a bit different way compared to the ordinary division of matrices what I had shown you some time back. Okay. Anyways, yeah, so we can even verify the answer. Obviously, how do we verify the answer? We do S star x. Okay, that will become equal to the vector b. Okay, so S multiplied by x gives you the vector b. That means the answer is correct. Okay, so just keep this in mind, that change which I had told you, that for division we use I divided by a or whatever. This helps in calculating a inverse. By the way, we could have even verified this, what we had done some time back. A star g will be what? A star g. This should give us the identity matrix. By the way, just a reminder, sometime back I had calculated G to be the inverse of the matrix A, right? I defined the matrix A here, and then I had defined G to be the inverse of A. But now when I do A into G, I don't exactly end up with the identity matrix, but I end up with something which looks something different. Okay, there are ones on the diagonal, zeros below the diagonal, but above the diagonal something else is there. Now these numbers are again small numbers. This is 10 raised to minus 16, 10 raised to minus 16, 10 raised to minus 16. Now this error has come because of the calculation. There was some round up error involved here when you are writing G. Okay, so when G was written, there was some round up error involved over here. Because of that reason, we are not getting a 0 over here. Okay, but whatever has come is 10 raised to minus 16, or it's a very small number, so you can ignore it. Okay, so that is there. So that was with regard to finding the addition, multiplication, and this thing, division. There's also something called term by term multiplication which you can do. Yeah, before going there, no, let me just finish off with the ordinary multiplication. I can multiply vectors also. Now just remember I defined M to be a 2 cross 3 matrix like this, right? So I'll define the product M. Let me just print M again. So this is the M which I defined sometime back. I can also give you another matrix called M transpose. M transpose is defined like this, M apostrophe. So it gives you M transpose. Okay, so I can define the matrix capital H I'll use now as M star M, wait, I'll put M transpose in a bracket just to avoid some trouble. Okay, so this gives you a 2 by 2 matrix. It multiplies M into M transpose. So 2 by 3 into 3 by 2 gives you 2 by 2 matrix. Okay, that is a symmetric 2 by 2 matrix also. Keep that in mind. Not only that, I can define the other way around also. Hij. I'll define J, capital J, to be equal to the other this thing. So to find transpose, just use apostrophe. That's what I'm trying to tell you here. M apostrophe star M. Okay, so this gives you a 3 by 3 matrix, which is again a symmetric matrix. Okay, so this being done, yeah, so some more basic things. So if I take this matrix H which I have just defined and I do H plus 3, let us see what happens. What has happened? It has actually added 3 to each term of the matrix over there. So H plus 3 gives you term by term addition over here. Term by term, each term of the matrix is added up by the constant 3. This is not mathematically well defined now, but the software is doing this over here like this, that is doing term by term addition of 3. Observe that this quantity is different from H star 3i. Oh wait, I is defined as something else here. Let it be. But H plus 3i is something else, obviously, that you know, right? Okay, keep that in mind. Not only that, you can do term by term multiplication also like this, H dot 3. So what will this do? Oh sorry, H dot star 3. Let's see if this works. Yeah, so what it has done, it has multiplied each term of the matrix by 3. Okay, so what I did, what is the command for term by term multiplication? H dot multiply, dot and multiply symbol gives you term by term multiplication. Okay, yeah, you can also do this. Let me just see if I have two proper. J is a 3 by 3 matrix. Any other 3 by 3 matrix I have? Yes, I have. Okay, so if I do this now, J is a 3 by 3 matrix dot star S. So what is done here is, it has done term by term multiplication of J and S. So the first term in J is the 1 term in J is multiplied to the A11 in S. Okay, here's S1. Yeah, S was this matrix. Okay, so this entry here is 7, the central entry. A22 is 7 here, and here we have in J 13 central entry. Right, so the product will be 13 into 7, so that is 70 plus 21, 91 should be there. Right, so we have 91 here. Okay, so that is how this term by term multiplication is done, and you can also define term by term division also like this. So capital J dot this slash S. Okay, so what has happened is, it has done term by term division here. Each term A11 is divided by B11, A12 is divided by B12 and so on. Okay, term by term division of matrices. Okay. Okay, so these are all the basic commands which we had in matrices. Okay, let us, how long is this video? Okay, I'll stop this video here and I'll do eigenvalues in the next this thing. Okay, so I covered only the basics over here of how to add matrices, multiply matrices, and perform basic operation on matrices. But keep in mind there are some strange operations in matrices when you're operating in SciLab. One is the division of matrices, something which you don't do in normal maths. Then we also have the commands for term by term division, term by term multiplication. This is something which we don't do in normal maths and this thing. Okay, but this feature exists over here and it has some uses. I'll show you one of the advantage of term by term multiplication of vectors in the next video. Okay, uh, so that's all what we could have done here. Okay. Okay, so that's all here. We'll stop here. In the next video, we'll continue with some eigenvalues, finding the inner products, and so on. Okay, so that's all over here. Thank you for watching. Bye bye.